passage is adopted from J.D. Watson and Mushigi, Genetical Implications of the Structure of Mushigi Acid. Watson and Katie did is the structure of DNA using evidence from Rosalind Franklin and R.G. Gosling X-ray Mushigi diagrams. Oh well, it's very complicated. So it's about DNA, I think. The chemical formula of Mushigi acid, DNA, is now well established. The molecule is a very long chain, a backbone of which consists of a regular alternation of sugar and phosphate groups. To each sugar is attached a nitrogenous base, which can be of four different types. Two of the possible bases, so adenine, guanine, I don't know if that's the right way to pronounce it, are purines, and other two, thymine or cytosine, are whatever it is. So far as is known, the sequence of bases along the chain is irregular. So far as known, it's irregular. The monomer unit consisting of phosphate, sugar, and base is known as the nucleotide. Definition of nucleotide. The first feature of our structure, which is of biological interest, is that it consists not of one chain but two. So, first feature, it's like the initial. These two chains are both coiled around a common fiber axis. It has often been assumed that since there was only one chain in the chemical formula, there would only be one in the structural unit. However, the destiny taken with the X-ray evidence, so it's the evidence from her, right? Rosalind Franklin. Rosalind's evidence. This suggests very strongly that there are two. Okay, so this is the new result, and this is the initial result. So now we discovered that there was two. Consist two chains. Okay. The other biologically important feature is the manner in which the two chains are held together. In the manner where the two chains are held together. So next question. New Q. This is done by hydrogen bonds between the bases. Hydrogen bond. Maybe it's like the design the experiment. The bases are joined together in pairs, a single base from one chain being hydrogen bonded to a single base from the other. The important point is that only certain pairs of bases will fit into the structure. So I think it's performing. Is it designing or performing? I think both. Design, perform the experiment. Only one member of a pair must be purine and the other this in order to bridge between the two chains. Okay, so one should be from this and the other should be from this. If a pair consisted of two purines, for example, there would be not room for it. This is the 부작용, I don't know what's in 부작용 in English. 부작용 of two purines. We believe that the bases will be present almost entirely in their most probable forms. If this is true, the conditions for forming hydrogen bonds are more restrictive, and the only pairs of bases possible are we believe that the bases will be present almost entirely in their most probable forms. If this is true, The conditions for forming hydrogen bonds are more restrictive, and the only pairs of bases possible are adenine and thymine, and guanine with cytosine. Adenine, for example, can occur on either chain, but when it does, its partner on the other chain must always be thymine. That's really confusing. What the heck? I guess this is like the result of the experiment. The phosphate sugar backbone of our model is completely regular, but any sequence of the pair's bases can fit into the structure. It follows that in a long molecule, many different permutations are possible, and it therefore seems likely that the precise sequence of bases is the code which carries genetic information. Oh my god. Right, the phosphate sugar backbone of our model is completely regular, but any sequence of the pairs of base can fit into the structure. It allows that in a long molecule, many different permutations are possible, and it therefore seems like the precise sequence of bases to code which carries the genetic information. If the actual order of the bases on one of the pair of chains were given, one could write down the exact order of the bases on the other one because of the specific pairing. Thus, one chain is, as it were, the complement of the other, and it is, this is the conclusion they came up with. Thus, one chain as the complement of the other chair, and it is this feature which suggests how the DNA acid might duplicate itself. Wow, I might have to read the whole passage again. By the way, this is the on annotations that I did. Oh wow, oh my god. Should I just reread it? I think I have to read it again because I don't get it. Okay. The chemical formula of DNA is now well established. The molecule is the very long chain, the backbone of which consists of a regular argination of sugar and phosphate groups. So okay. Also, it's explaining the structure of DNA. The backbone, sugar, and phosphate argination. To each sugar is attached a nitrogen base, which can be 4 different types. 2 of the possible bases, adenine and guanine, are purines, and the other 2, thymine and cytosine, are P whatever. So far as is known, the sequence of bases along the chain is irregular. The monomer unit consisting of phosphate, sugar, and base is known as a nucleotide. The first feature of our structure, which is of biological interest, is it consists not of one chain but 2. Initial result or initial belief. These 2 chains are both coiled around a common fiber axis. It has often been assumed that since there was only one chain in the chemical formula, there would only be one in the structure unit. However, the density taken with the X-ray evidence suggests very strongly that there are 2. New results. There are 2. The other biological important feature is the manner where the 2 chains are held together. This is done by hydrogen bonds between the bases. The base joined together in pairs, a single base from one chain being hydrogen bonded to a single base from the other. The important point is that only certain pairs of bases will fit into the structure. One member of a pair must be purine and the other a bushigi in order to bridge between the 2 chains. If a pair consisted of 2 purines, for example, there would not be room for it. Not 부작용, but like a result of 2 purine. Okay. Result of a 2 purine. We believe that the bases will be present almost entirely in their most probable forms. If this is true, the conditions for forming hydrogen bonds are more restrictive, and the only pairs of bases possible are adenine with thymine, which is 1 purine and 1 whatever it is, and guanine and cytosine. Yeah, so like pair of 1 and 1. But when it does, its partner on the other chain must always be thymine. The phosphate sugar backbone of our model is completely irregular. Oh, wait, what was irregular? This is regular? Oh, base? Okay. But any sequence of the pair's bases can fit into structure. It follows that a long molecule may different permutations are possible, and it therefore seems likely that the precise sequence of bases is the code which carries the generic information. Oh wait, no. Okay, let's say this was not initially believed. This was a hypothesis. Yeah. Hypothesis, and this was like another result they got. If the actual order of the bases on one pair of chains were given, one could write down the exact order of the bases. Specific pairing. Yeah, the specific pairing means one in purine. I'm so sorry. Specific pairing means one in purine and one in pyramid, something like that. Thus, one chain is, as it were, the complement of the other, and it is this feature which suggests how the DNA acid molecule might duplicate itself. So this is the actually question, like how the DNA molecule might duplicate itself. It's the question. Okay, this is a table. Adenine, guanine, cytosine, thymine, organism. Okay. Let's go. The authors use the word backbone in line 3 and line 39 to indicate itself. Let's go back to line 3. Backbone. And 39. Backbone of our model. I said structure, so maybe to explain structure. Only very long chains of DNA can be taken from one organism with a spinal column. The main structure of a chain in DNA molecule is composed of repeating units. I don't think it's repeating units. A chain in DNA molecule consists entirely of phosphate. No, not entirely. Oh, wait. I think it said about, here. Okay, shut up. Here. The phosphate sugar backbone of our model is completely regular. Oh, wait. No, not here. Huh? Oh. Oh my god. I'm so bad at this. Nitrogenous bases from the main structure unit of DNA. I don't think it was nitrogenous bases. Let's just skip this problem. I'm so sorry. A student claims that nitrogenous bases pair randomly with one another. Which of the following statements in the passage contradicts the student's claim? Okay, 5 to 6. Oh, maybe I should have known this. Okay, let's go with prephrase. I think it would maybe like in second paragraph, because the first let's say after first paragraph, because this was mentioned in the first paragraph, so maybe second paragraph here. Oh, I was actually right. Okay, so 13 to 15 or something. Oh, never mind. Mr. Team. Wait, nitrogenous bases. Okay, I'll just end the video right now.